Sir, I got the answer as 2017.
Okay, this
It
is
was
correct.
40 short.
How? Tell me.
So root A plus
Hmm.
9 root B plus 44 root C
Hmm.
whole square is equal to A
Hmm.
should be greater than equal to
Should be
A
less
plus
than equal to.
less than equal to A plus B plus C
Hmm.
1 plus 81 plus 44 का whole square. So that would be 2018. Yeah.
Right. So this square should be less
Huh.
than equal to this, right?
Yes.
That is
If it's
Cauchy's
equal,
inequality.
yeah. So if it's equal,
Hmm.
we should say root A is equal to root B by 9 is equal to
Hmm.
root C by 44. So we'll
So
get,
right now we are having equal to 2018 A plus B plus C on this side. And
yeah,
in the question they said that it is equal. So that means it's the equality case of Cauchy's inequality, right? So that means we can take the ratio of root A with 1
yeah,
and
is
root
equal
B
to
with 9 and root
root
C.
C
Hmm.
44.
And from
So
here we will get the B as 81A, for example, and we get
A,
C as 44 square into A,
8.
and then we can find B plus C by A as 2017.
Huh.
Okay, so that is the correct solution. Then the next one was an equation, right?
Yeah, so I got the answer 49.
1 second. The equation was x minus square root of 2018 plus root x equals 4.
So I got
The
the answer
answer
49.
49 is correct. How? Tell me.
So x minus 4 is equal to under root
Mm-hmm.
1018 plus root x. Then we
Hmm.
whole square both the sides, so x minus 4 whole square.
Hmm.
Um, yeah, plus 16 is equal to 2018 plus root x. Now we can take root x as t and
Hmm.
6 to the power 4
Hmm.
to power minus 8 t square plus 16 is equal to 2018 plus t. So
Hmm.
t to the power 4 minus 8 t square minus t minus 2002.
Hmm.
And there is a theorem in which it says like 2002 factor should be t, like, so
No,
it,
but that theorem is only if you know it is rational roots, no?
yeah, so
Right now, the question was saying solve in real numbers.
but sir, actually there is also one theorem that how many sign changes are there, so that many positive solutions are there,
But
and
that will not give you the answer, no?
so it tells us that there's one positive root, and if we substitute like 7 in it, it will get an answer. So I got it by that.
So see, the thing is,
Sir,
the change of sign theorem that you are saying, that will tell you the number of positive roots and number of negative roots, right?
Yeah, so there's one positive root.
But it doesn't tell us the root, correct?
Yeah, so we can substitute 7.
So right now, the question had asked us to solve for real numbers, but when you get a higher degree equation, it is good to check for some small simple root, right?
Yeah, so I
If
first checked it for 3 and 4.
hmm,
Then I got a hint to check it
sir,
for
hmm,
7.
sir, I have a better solution for this.
what?
Sir, basically first I did the guesswork and I got 49 as one of the solution, and then I proved that it is the only solution.
Okay, how do you do guesswork and get 49 though?
Sir, basically it is close to 45 square, 2018 plus root x. So I substituted 49 directly, and then the trick that you taught us कि हम इसे प्रूव कर सकते हैं कि ये इंक्रीजिंग फंक्शन है,
Hmm.
उससे मैंने प्रूव किया कि ये इंक्रीजिंग फंक्शन है, तो उससे हमें मिल गया कि ये सिर्फ एक बार कट करेगा.
Okay, if you can guess the solution, then great. If you guess the solution, then you can check that the left hand side is increasing or decreasing. And if you check whether it is increasing or decreasing, if it is coming like it is monotonic, then you know that there will be only one intersection.
So,
So that is correct. That is fine. But guessing is the difficult part then, right?
yes.
Here also you have to guess. And if you guess that t is equal to 7 satisfies, then it is over because you can take factor out, right? If you take a factor out t minus 7, you will get something like this: t cube plus 7t square plus 41t plus 286 equal to 0. This is what you're getting, right, Aradhya?
Yes, sir.
This should have no solution.
Yeah, because of sign change, I checked it should not have solution. So I just took t is equal to 7 because
Or
t
you
should
can
be
also check by taking the derivative and seeing derivative is 3t square plus 14t plus 41. B
yeah,
square minus 4ac will be negative for this.
yeah. We can check it
And
by that, but
uh,
sign rule was easy
hmm.
for me.
So if t is equal to 7 is your solution, then x will come as 49.
Yeah.
Okay. The next problem was 55.
I got an answer. X is equal to 20, y is equal to 23, and z is equal to 33. It was done by Cauchy shorts only. I did it by Cauchy shorts.
Okay, 1 second. Let me just write the question. X square plus y square plus z square is equal to 20x plus 33y plus 33z is
23 items.
23y plus 33z is equal to 2018. So what have you done now here?
So 20x plus 23y plus 33z whole square should be less than equal to um, x square y square, x square plus y square, yeah.
This square into x square plus y square plus z square.
So it's 2018. It's also 2000. All the terms are 2018. So we know that
So we are getting middle term here is less than or equal to this into this, but we already know this is equal to this. So this
yeah,
is 2018 square. So we are getting middle term should be less than equal to 2018 square, but actually it is equal. So
yeah,
that means you have equality case again.
yeah.
So you have this situation. Now x and y and z could be in a ratio like 20k, 23k, 33k, right?
And we can
But
substitute in the above equation.
if
So
you
we'll get,
substitute in one equation, you can get a possible value of k,
yeah,
right?
that it would be 1.
K is equal to 1 is coming and no others will come.
Yeah.
Okay, fine.
सर,
Hmm.
इसे भी मैंने थोड़ा डिफरेंट किया था. मैंने परफेक्ट स्क्वायर का सम क्रिएट किया.
That is also fine. You can do that also. You can make it a sum of 3 perfect squares. You can do it like that also. For example, you will get x square minus, you can so do x square minus 2 into 20x. Ruko. X square minus 20x plus 20x नहीं 40x चाहिए. Minus 2 into 20x plus 20 square plus y square minus 2 into 23y plus 23 square plus z square minus 2 into 33z plus 33 square. This expression, I have done what? I have subtracted this stuff and added this stuff, right? So, okay, so this expression is basically x minus 20 whole square plus y minus 23 whole square plus z minus 33 whole square, right?
0.
And if you check, this plus this plus this is 2018, and this plus this is also 2018. So 2 times 2018 minus 2 times 2018. You should realize that this expression is 0.
Yes.
Aradhya, are you understanding what is happening?
Yes, sir.
Basically, you are getting that this sum of three squares is 0 because of the fact that this was all equal to 2018, right?
Yeah.
So
Yeah.
from there, we can conclude immediately that x is 20, y is 23, z is 33. So that is also a nice solution. Okay, let's move on. Problem 56. This has, okay. Solve in distinct real numbers. Solve in distinct real numbers. The system of equations. We have xy by x minus y is equal to 1 by 30. And we have x square y square by x square plus y square is equal to 1 by 2018. These two equations we have to solve. You have to think of a way of writing the equation in a nicer way. Right now, it's a horrible setup.
Sir, x comma y is equal to 1 comma 1 by 559 and x comma y is equal to 1 by 559 comma 1.
What are you saying? You're giving me the answer.
Yes, sir.
What is x for you?
Sir, x is 1 and y is 1 by 559.
No. Have you checked and put it in the equation and seen whether it fits? Check it once in any equation. Is it fitting?
No, sir.
हाँ?
No, sir.
तो फिट नहीं हो रहा तो सॉल्व कैसे हुआ? Before saying the answer, at least check it, no? I would suggest in this question, take reciprocals first. If you take reciprocals, things will be easier. You'll have x minus y by xy.
1 by 13 comma 1 by 43.
That is correct. There is one more pair of solutions. 1 by 13, 1 by 43 is correct. If you take reciprocals, you will get 1 by y minus 1 by x is 30 from here. And from here, you will get 1 by y square plus 1 by x square is equal to 2018. This is a much better system of equations to try to solve. Because we can take advantage of our normal square identities. Basically, you can say that 2 by xy is equal to 1 by y square plus 1 by x square minus 1 by y minus 1 by x whole square. This is an identity, right? This is a simple identity. So we are getting 1 by y square plus 1 by x square is 2018 minus this is 1 by y minus 1 by x whole square is 900. So we are getting 1118 is 2 by xy. You're getting xy is equal to 1 by 559. 559 is 43 into 13. Now you have to check how it fits.
Sir, I got this same thing in another way.
But your answer was wrong. So it doesn't matter how you got it. Do you understand that finally it is whether you get the correct answer or not that matters?
Yes, sir. Yes.
लेकिन तुमने तो आंसर गलत बोला था. We have gotten one thing right now. We can also get 1 by y plus 1 by x whole square. That will be 1 by y minus 1 by x whole square plus 4 by xy. So we already know this is 900 plus 2 times 2 by xy is 1118. You will get 1 by y plus 1 by x will come out to be 56. You can check that. If 1 by y plus 1 by x is 56 and 1 by y minus 1 by x is 30, it is obvious how to solve that then. Here, it comes as square, so you could also take the minus 56 option because you'll get 1 by y plus 1 by x whole square is equal to 56 square. If you take the minus 56 option and then check the answers, you will get the other pair of roots, which is minus 1 by 43 and minus 1 by 13. I hope everybody is understanding what I'm saying.
Yes, sir.
There are two pairs of roots. We are trying to find this square. We'll get it as 56 square. It is a standard problem. It's not very difficult at all. Don't try to guess from here. If you try to guess from here, you will end up with answers like 1 by 559 and 1. The best way to solve is not starting to guess here. You need to solve 1 by y plus 1 by x and get exactly what is 1 by y and 1 by x. I hope that is clear to everyone.
Yes.
Okay, next one is this one, problem 57. Find the greatest real number x such that x times GIF of x is equal to 2019 fractional part of x. This is fractional part function. This is GIF. That's it. This is the question. Solve this equation, basically. Any way, anything?
Sir, I didn't get the solution yet,
Hmm.
but I thought there could be a way. So fractional part of x can be written as x minus greatest integer of x,
Hmm.
and we can take greatest integer of x as y. I thought this is a way, but at the end I'm getting a weird equation.
Hmm.
I think this is the way. So greatest integer of x we can take it as y.
Okay, but how will that help?
It will be two equation, two variable. Sorry, equation and variable. Um, like 2009. We can factorize this basically.
Okay, you try it out. First of all, think about what is the question. They are asking us to find the greatest real number x such that this happens. So we will first try the case where case is the x that we are thinking about is a positive number. Let's think of those cases where x is positive, because it is likely that we are looking for a greater number, it should be positive. In that case, let's check if there is any solution to this equation for that situation when x is positive. So if x is positive, then we know that GIF of x will be greater than equal to 0, right? Correct? Is that clear? If x is greater than 0, obviously GIF of x will be greater than or equal to 0.
Yes.
Yes.
Now think about it. The GIF of x whole square is clearly going to be less than equal to x times GIF of x. Is everyone agreeing with this? Because by definition, x is bigger than GIF of x, right?
Yes, sir.
By definition of GIF, x is bigger than GIF. So this inequality is correct, right? By the equation, we know that this is equal to 2019 fractional part of x, right? Correct. And fractional part is always less than 1. So therefore, this is less than 2019, right? Do you
Yeah.
understand what I'm saying? So from this set of inequalities, this chain of inequalities, we can conclude that GIF of x square is less than 2019, right? So that means, now check squares and all, I think you will get that GIF of x is less than equal to 44. 44 squares how much? 44 square is 40, 1600 plus 160 and 16.
I
Sir,
guess
the answer is
136.
44 whole 1936 by 1975.
That is the answer. Is everyone understanding that this is less than equal to 44?
Yes, sir.
Because I think 45 square is above 2019. 2025 or something, no, 45 square. Correct?
Yes, sir.
So from there, because we want to maximize our x, let's take the case that GIF is equal to 44. If it is not equal to 44, we will have to check a lower case then, right? Correct? I hope everyone is following what I'm saying. I'm taking the largest possible number where GIF is 44, right? Then we will get, from the original equation, we will get 44 times 44 plus fractional part of x should be equal to 2019 fractional part of x, right? From here, we can find the fractional part, no? We are getting this equation. I hope this equation is clear to everyone.
Yes, sir.
So from here, we are able to find a fractional part of x, which is coming out to be 1936 by 1975. We are taking the largest possible GIF and then we got the fractional part. So obviously the X number becomes 44 plus 1936 by 1975, right? There is only one solution when GIF was 44. The only one solution for fractional part was this, right?
सर इसको तो ऐसे भी कर सकता है कि मैंने मान लिया कि x इक्वल टू I प्लस f, फिर I is the greatest integer part and f is the fractional part. So it would be I square plus if is equal to be 2019 into f, or f is equal to be I square by 2019 minus I. Now f is clearly less than 1, so I square is less than 2019 minus I, और इसको solve किया तो आया I less than 45. So I का जो greatest integer value है वो है 44.
It's the same thing what we have done in a different way, right? This is the same thing that I am also saying.
Okay, sir. Okay, sir. समझ गया.
You are solving it in a different way from here, which is correct. It's a good solution. You can write it like that. You can say the equation becomes I plus F times I is equal to 2019 F, and solve for F from here. If you solve for F from here, that F must be between 0 to 1. And from there you get the same conditions that we also got. I hope it is clear to everyone what is happening. सबको clear है ना ये?
Yes, sir.
Okay. 1 second. Okay. We move on to the next problem then. Problem 58. Here we have find all pairs A comma B of integers such that x cube plus ax square plus 2019x plus b has two equal positive integer roots. So a question on polynomials, you have to find all pairs of integers a and b so that this polynomial has two equal positive integer roots.
Sir, is it coming minus 2011 and minus 1009?
One of the answers is right, one is wrong. You made some calculation mistake. Check once. It is not minus 2011, minus 1011.
Oh, yes, sir.
And there is another option also. There are two pairs. You have to get the other one also. Twenty 2019 can be factorized not just as 1 into 2019. It's not a prime number. It's divisible by 3 also.
It's 3 into 673.
So if you take m as 3, or whatever is your integer root as 3, one of them, right?
Yes.
You will get another different equation then.
हाँ, वो मैंने miss कर दिया.
So in the different equation, you will get minus 341 and minus 3015. So basically the question is actually very easy here because you have to have two equal positive integer roots. So let's call that equal positive integer roots as m and m, right? The third root of this will be some other integer n. Everyone should understand that the third root will also be integer. Do you understand why third root has to be an integer?
Yes, sir.
Why?
Sir, because B is integer and M square into N would be.
B and A are both integers, so A will be the sum of the roots, right? So A is integer, that means 2m plus n is an integer, which means n is an integer because m is an integer, right? And from here, and then using Vieta's formulas, you should get 2m plus n. One second. By Vieta's relations, what will we get? M plus 2n. M plus n is equal to minus a. And then we get m square plus mn plus mn, right? Is equal to 2019. And we get m square n is equal to minus b. Correct? I hope this is clear to everyone. So we are getting n plus 2m is equal to minus a, and m square plus 2mn is equal to 2019. And you should try to use your knowledge here. 2019 is 3 into 673. 3 into 673, which are prime numbers, and here we can factorize it as m into m plus 2n is equal to 3 into 673 or is equal to 2019 into 1. So there are two options of m and m plus 2n, which is what you have also done, Aradhya, right? M could be 1 or 3 and m plus 2n will be 2019 or 673. And after that, you have to find the values of A and B from there in those two cases. If you do the calculations carefully, you will get these answers. I hope it is clear to everyone. Is there any doubt here? Okay.
No.
We'll move on to the next one. This is let f be a function from R to R such that f of x is equal to 20x minus 19 for all x belonging to real. First part is find f of 1. Second part is prove that such a function exists. Prove that such a function exists. Any ideas? First, I would say you should notice one thing. If you put x is equal to 1 here, what happens?
Sir, f of 1 is equal to 1.
What is the reason? Why should f of 1 be equal to 1?
सर मान लिया कि f of x is equal to ax plus b. So f of x is equal to a into ax plus b is equal to a square x plus ab plus b, और a square x plus ab plus b is equal to 20x minus 19. So इसका कोएफिशिएंट को सिमिलर किया तो ये हुआ कि a square is equal to 20. So a is equal to root over 20 and b into a plus 1 is equal to minus 19. इससे आया कि b is equal to 1 minus 20 और f of 1 is equal to b.
What? b is equal to what?
1 minus root 20.
1 minus root 20. You are getting the other equation for you was you got a is equal to root 20 and the other equation was ab plus b is equal to minus 19, right?
Yes, sir.
b 1 plus a is equal to minus 19. So b is coming as minus 19 by 1 plus root 20, right?
Yes,
Then
sir.
you have rationalized it.
Yes, sir. 19 को. Yes, sir. Yes, sir.
Okay, so you're getting 1 minus root 20. Okay, so your f of x is coming as root 20x plus b. So plus 1 minus root 20.
और f of 1 is equal to 1.
Okay. But here what you have done is you have assumed that it is a linear function for which this condition, if you check, the linear function comes out to be this, right?
Yes.
Where f of 1 is 1, that is correct only. But
Sir, if this
f of
is
1, no, 1 second. F of 1 is equal to 1 should have come without assuming a linear function. This is the second part. You can show that a linear function you can find which will satisfy it. What I want you to do is find f of 1 without assuming that it is a linear function. समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir. समझ में आ रहा है.
You should be able to prove f of 1 is 1 without checking this like this. This part is the proof that such a function exists because you have found a function which exists. So second part you have done, but first part you have to do without second part. Try to think of a way to do first part without taking this like this. Anybody else? Anything for f of 1? The way to do this first part is in this equation, we can put x is equal to f of 1 in this equation. So left hand side becomes f of 1 is equal to 20 f of 1
ऐसे ही
minus 19, right? Now, because we know that f of 1 is 1, if you put another f outside it, f of 1 will be f of 1, right? सबको समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
So this left hand side is actually f of 1 only, right? Because f of 1 is 1, put one more f. So that will be f of 1, right? You're getting f of 1 is 20 f of 1 minus 19. And basically now you're getting f of 1 is 1. But so far in this solution, we have not made any assumption about the nature of the function. We have not assumed that it is ax plus b. It could be anything as long as it satisfies this condition. Is it clear to everyone what I'm saying?
yes sir I also found it.
So second part, to prove that such a function exists, we can say that let fx ax plus b, and we are able to find a linear function that satisfies these conditions. So that is fine. But the first part, you can do it without doing that. I hope
Yes,
it
sir.
is clear. Okay. Problem 60 and problem 61 is homework. Problem 60 is find all triples PQR of primes such that PQR minus 18 times P plus Q plus R is equal to 2019. This is 60. Problem 61 is let AN, where n is greater than equal to 0, be a sequence of positive real numbers such that A3 is equal to 2019 and AN plus 1 is equal to 2 power n minus 3 AN times AN plus 1 plus 3, where n is greater than equal to 0. You have to find A0. So write down these questions. This is your, okay, I'll give you one more problem, which is interesting. Have you written down these two? Write down these two first.
Yes, sir. We have written.
Everyone has written. Write down, everyone write down and tell me if
Yes,
you
sir.
written. Okay. Problem 62 is this one. The 13-digit number capital N is equal to And we are writing the number with the digits in the normal number notation. We are writing it A, B, C, D, E, F, G, H, I, J, and then K, L, M. These letters are digits, by the way, right? The 13-digit number is divisible by 101. Find the digit A. Find the digit A, knowing that B, C, D, E, F, G plus 2019 is equal to H, I, J, K, L, M. Is everyone understanding the notation?
Yes, sir.
These are numbers. This is a 6-digit number. This is a 6-digit number. This is a 13-digit number, which is divisible by 101. And you have to find the digit A. Write down the question. That will be your third problem, which you can try. So tomorrow we'll discuss these 3 and more questions. Let me know if you have written it down. That's all for today.
Bye, sir. Thank you.
Bye, sir.
Good evening, sir.
Bye.